That's sad. I had already finished it, so I didn't realize it wasn't recording for the second half. So missed all the in between, but what I have here is that there's a get indexes that returns the valid range, given 2 points in a window indicated by 0 and then whatever ceiling value there is. We need to take into account the direction, because A could be less than B or greater than it. And then what we do is we just find the range here. I find that this stuff is completely impossible to talk about. It's like patterns that happen in your head that's like really difficult to explain. But the get index is what it does is it returns, given it's kind of like these 2 points. Maybe this will be easier to talk about. If we just draw out 1, 2, 3, 4, 5, 6, 8, 9, 10, and there's also 0. Okay, so this is our range, and we're only thinking about one dimension. But if we have kind of this number, we have these 2 antennas here between 2 and 5. There's going to be, according to the rules, you're going to have antinodes every step of 3 out. So we wanna make clear that our bounds are in between here. So just indicating that we can actually step out of these bounds, and we want to throw those points away. So the range that we want to consider is between 0 and 10, just for example. And then you have these 2 points, which are you have these 2 antennas here, indicated by the A. And actually, I'll do it this way. Okay. Okay, so you have those 2, but then you also have antinodes on these as well. Just to keep those single digits so that it makes sense from a representation. Okay, so you have all these antinodes that are 3 apart from each of these antennas. So the problem is that we have to indicate what the indexes are. So if this is, let's just say A to B, then you're going to have index 0 here, 2 here, sorry, 1 there. Am I doing this right? Plus 3, plus 3, plus 3. Yes, 3. And then this over here is actually -1 as well. So I'm indicating here that this is X, and then this is I. So this is the actual range, and just to be completely clear that this is 10 and this is 11. Okay, so I hope this representation is not too confusing, but we have antinodes here and then the antenna, and then you have these indexes. But if the direction is flipped, like if you're going from A to B, for example, if we're starting at A, then we need to change the index, the indices. So this will be 0, this will be 1, this will be 2. -1, and then -2. So you can see that the directionality does change the indexes. But we always want to only keep these. We want to only keep the ranges within the window that we were given. And again, this is just the ceiling that we're passed into the function. And this is A and B, but they can flip. So the min I is according to It's just the minimum of the indexes. So here the minimum is going to be -1, and then for here, if the direction is flipped, it's actually just going to be 0. So that's all this does. But in the 2D case, we do have to realize that we're going to have different ranges. We're going to have an index range for the x, and then an index range for the y. So we just take the intersection between these two things, the intersection of those ranges, and then we generate all the points from there. It's a little bit hard to illustrate the 2D case, so I'll just leave it at the 1D. And that was it. It's just a matter of really just looking at the 1D case here. Oh shoot, I'm not supposed to be sharing this, am I? Because it's like a contest thing. Okay, well that's what I did. All right. It's very interesting because you really just have to solve the 1D case and then figure out how to intersect it in the 2D case. There's probably some ways to brute force this, and maybe there's like more clever ways to look at it. Like if I'm going through the table here, maybe there's some kind of mathematical thing where at this point, maybe it's the same as the other two antenna points, modulo some number. I don't know. I think that's probably... Yeah, if I look at it right here, it looks like it would just be 2 to 5. So all these numbers are going to be equal modulo the distance between B and A, so that would be 3. So you really do just have to iterate through every single one of these things and then see, is it That's so cool. So I don't even need to compute all these nodes. All I have to do is iterate through every single one of these. Well, it saves time pre-computing these index ranges. So I guess this amount of work, what it does is it ensures that we are only going to look at the points that we want to convert into nodes, antinodes. But if we just iterated through every single one of these things, which it doesn't really matter, because look at how big that is. It's not big at all. So if I just iterate through these things, I just have to see if it's equal modulo the distance. So it looks like so it makes sense because 5 and 2 are both equal modulo 3. And then every other point is going, like 8 is the same as, well, what is 2 modulo 3? It's 2. 3 modulo 5 modulo 3 is 2, 8 modulo 3 is 2 as well. So all of these things are the same modulo, that number. So I would just have to go through every single coordinate and see if x and y are equal to... Are you going to bed? Okay. All right, sweetie. Mm-hmm.